Hello, welcome to Chapter 5, Section 2. We're talking about the properties of the quadratic functions. And we're going to introduce the idea of standard form. So here's what we know so far. In 5-1, we learned about vertex form. And if you're watching these videos in order, you saw me just talk about that. Vertex form has this. The function, whether it's f, g, whatever, I have some number multiplied by x subtract h inside parentheses. This part inside parentheses is being squared, and then I add k at the end. Now, remembering transformations, from the parent function, this is a horizontal translation, either left or right, by h. If h is positive, it'll say x subtract something, and if h is negative, it'll look like x subtract negative, which looks like addition. But this tells me how far left to right to go from the parent function, and the parent function, the vertex and the axis of symmetry, well, the vertex is on the y-axis, and the axis of symmetry is the y-axis. Okay? So this tells me how far left to right away from the y-axis. Multiplying by a, we're not going to worry too much about that. Sometimes a can be negative, that means it's a reflection. This could be a vertical stretch or compression. And then k tells me how far up or down. So if I ignore a for just a moment, h and k tell me the vertex. And of course a just tells me the vertex doesn't change because of a, but a would actually represent whether it is horizontally, vertically compressed or stretched, or even if it's upside down. Okay, that's all good. Standard form of a quadratic function, which actually is standard form for any polynomial function. Later in this quarter, when we get to chapter 6 and we talk about other polynomial functions, so x to the 3rd power or x to the 5th power or x to the 19th power, we're going to find out that standard form is consistent. The only time that we call something standard form and it doesn't fit this pattern is with linear equations. And there's a reason for it, but I wish we didn't do it. If you remember linear equations, you remember slope-intercept form, which would be, it would look just like that. Okay, except that we usually use an m and we use a b. But it's the same idea. You multiply x by something, we add something else. So the a, the b, and the c, those are not variables, by the way. Okay, they are parameters. So a, h, k, a, b, c are not variables, they are parameters. Parameters are numbers, constants that represent various things, like I said, stretch, compression, and then the vertex. They represent various things inside of one function. The parameters for another function might change, but that doesn't mean that they are variables. So please pay attention to that. Standard form has 3 parameters, a, b, and c. And here's the important part. I have to have x to the 2nd power. So a, b, and c can be any numbers at all, except a cannot equal 0. If a equals 0, it's not quadratic. It's going to be linear. So I have to have a not equal 0, any number other than 0. They can be fractions, they can be positive, they can be negative, anything, and it's going to be quadratic. All right? All right, so now, how do I figure out what the a, the b, and the c are? So watch what I'm going to do here. Let's start with vertex form. X subtract h squared plus k. And all of these are going to be named f of x, okay? So I'm not going to worry about that. I'm just going to focus in on this algebraic expression. The first thing I'm going to do is I'm going to multiply x subtract h times x subtract h. X minus h squared means I take this and multiply it by itself. Now, you probably learned how to do this in Algebra 1. I'm hoping that you did. I will, when I get them recorded, I will post a link to some of the Algebra 1 videos that I do so that you can see how to do this. But for now, this is something that you should know how to do. So x minus h squared means x subtract h times x subtract h. You probably learned it by FOIL, and I'm not going to waste any recording time talking about why I don't like FOIL, okay? It's a trick, it's not a good way of doing it. I like explaining it using the way the original mathematicians were doing it. X subtract h, x subtract h, I get x squared, negative hx, and h squared. So when I put that all together, I get x squared subtract 2hx, and remember, h is not a variable, it's a number. So whatever h is just negative 2 times that, plus h squared plus k. Now I'm going to use distribution. I'm going to multiply a by all of this. So I get ax squared minus 2a times h times x. That's a lot of letters to put together. Only the x is a variable. The a and the h are not variables, they are parameters. So this is just a number. Plus a times h squared plus k. All right, now check this out. This, I'll go ahead and call that f of x now. This is standard form. Here's x to the second power, here's x, and everything else are parameters. So I want to compare that to the other way of writing it. F of x equals ax squared plus bx plus c. So check these out. The a's are the same. So a equals a. They're the same. So that a is the same as that a. This part right here, the a times h squared plus k, that's the same as whatever c is. And that looks like it might be complicated and you might need to remember that for later. You don't. Just, it'll be okay. But this is the big one. This is the important one, okay? Negative 2a times h equals b. So in other words, this part right here equals that. They're both being multiplied by x. And as always, pause and look at it. Take your time. Why is that important? Why? Why is it important? Because the axis of symmetry is x equals h. But if I have standard form, I don't know what h is, but I can figure out what h is. Take negative 2a h equals b, divide by negative 2a, and h equals b divided by negative 2 times a. So finally, that tells me that my axis of symmetry is x equals b over negative 2a. So if I have standard form and I know what a and b are, I can figure out the axis of symmetry. The c doesn't affect the axis of symmetry. The c is actually the y-intercept, and we'll get to that in a little bit. So let's summarize what we just learned here. And this is a lot. This video is going to be a little bit longer, okay? So get some popcorn. If I have a function in standard form, a, b, and c are real numbers, and like I said, a does not equal 0. Okay, so in other words, it doesn't become linear. Here's what I know about the properties. First of all, the parabola opens upwards. It makes a U or a smiley face if a is positive. That goes back to this. If a is positive, it makes a U-shaped parabola. If a is negative, it flips it upside down, and it makes a frowny face. The axis of symmetry, I figure out what the b is, I figure out what the a is, and I do b divided by negative 2 times a. Now I put the negative 2 next, sorry, I put the negative next to the 2. Either way, it's fine. Negative divided by positive, positive divided by negative are all negative. So this is okay. Now this is where it gets a little tricky. The axis of symmetry, this red dashed line, bisects, and that's a bad way of saying it, but it cuts the parabola in two parts. But it crosses at the vertex. Right here is the vertex. So whatever the x value is of the vertex, that's the x value that represents this vertical line. All of the points on this line have the same x value, including the vertex. So when you find that axis of symmetry, that's the x value of the vertex. How do you find the y value? Well, remember, this looks complicated, but it's not. It'll be x equals 3 or x equals -5. You're going to take that x value and you're going to put it into the equation. You're going to get a y value back, and that will be the y value of the vertex. So I'll show you how this works. Finally, the last thing in this section, the y-intercept, is just C. The y-intercept is where it crosses the y-axis, and the equation for the y-axis is, it's a vertical line. The equation for the y-axis is x equals 0. So if I let x equal 0 and x equals 0 here, I just get C. So that's the y-intercept. Okay, so we're going to take this function. It's in standard form. F of x equals x squared, subtract 4x plus 6. We're going to find whether it opens upward or downward, the axis of symmetry, the vertex, and the y-intercept. Now, the problems, I'm going to hide this for a second. The problems then say, graph the function. But in preparing for this video, I thought I'd do something a little different. I thought I'd go ahead and graph it. And the reason why I did that is because when I find all of these things, I'm going to look at the picture and see if it's true. So we're going to confirm it by looking at the picture. I already graphed this on Desmos and took a screenshot. And yes, this is that graph. All right? So when I find the axis of symmetry, I'm going to show you where that is. Same thing with the vertex and the y-intercept. The first thing I need to do is I need to know what my parameters are. What am I multiplying by the x? So I get a equals 1, positive 1. I'm sorry, and I said x, I meant x squared. What am I multiplying by this x? My b equals -4, and my c equals 6. So I found my parameters, and remember what I said, the parameters are not variables. 1, -4, and 6 are not variables. I'm just giving them names. I'm giving them nicknames. That's all I'm doing. Part A, and don't confuse this with those, okay? Some people do that. Does the graph open upward or downward? A equals 1, and A equals +1. So it opens upwards like a smiley face. I'll put arrows in, but don't put arrows in, okay? Because A is greater than 0. Now, when you do this on a test, you can't just say upwards. You need to tell me why it's upwards. And you can do it in different ways. They all mean the same thing. You can either say, well, because A equals 1. You can say because A is positive, or you can say because A is greater than 0. You just have to tell me why. Now look at the picture of the graph. It does open upwards. So it does look like a smiley face. What's the axis of symmetry? So the axis of symmetry is x equals b divided by -2a. My b is -4. Just going to do my work right here. -2 times a, my a is 1. Now this is like elementary school math. Multiply the bottom, divide. You can do it. Sometimes, spoiler alert, sometimes you're going to get a fraction. Don't worry about it. But in this case, it's going to be nice. -2 times 1 is -2, and -4 divided by -2 equals 2. And if you stop and write 2, it will be wrong. Rewind that. If you stop and just write 2, I will not count it. The axis of symmetry is a vertical line. Vertical lines require an equation, so make sure that you need the x equals. Otherwise, you just give me a number. Now, where is the vertical line x equals 2? So start at 0, go to the right 2, and then I'm going to draw a vertical line which looks like that, no arrows. Now, if we were doing this the right way, we would just have that line. But I've already put the graph on there. That's the axis of symmetry. It cut the parabola into two parts that match up. I'm hesitating using the word congruent. Congruent is probably correct, but I don't want to mislead you about some other stuff. We use congruent in other ways. Okay? All right. Now there's the vertex. Let's find out if we can find it. I guess I repeated myself. Let's find it using this. I know that x equals 2, so I'm going to put 2 where the x is. F of 2 equals 2 squared, subtract 4 times 2, plus 6. This is easy. Take care of the exponent first. 2 to the second power equals 4. Take care of multiplying next. 4 times 2 is 8. Now, you just got a bunch of things you need to add, and that's negative 8. You can add 4 plus 6 and get 10. 10 plus negative 8 equals 2. Or you can do 4, subtract 8 is negative 4, negative 4 plus 6 is 2. The associative property falls in here. It doesn't matter which 2 you start with. But I get my y value is 2, so my vertex, the x value is 2, and my y value is 2. And that's right here at 2, 2. And finally, the last thing I need to do for this section, what's the y-intercept? The y-intercept is just that number right there, 6. And it's not x equals 6 or y equals 6 or anything like that. It's just 6. And that's right here at 6. So that's how we do that one. Let's do another one. And I'll pick up the speed a little bit because I know this video is getting a little long. I knew this one was going to get a little long because this is where most of the information is. New function. f of x equals negative 4x squared, subtract 12x minus 3. This is the graph of that function on Desmos. And notice also, I did one thing on Desmos. It looks like from here to here is 10, but from here to here is 5. I did that. I spread it out a little bit more so it'd make it a little bit easier to see. I just want to draw attention to that. Okay? My a is negative 4. My b is negative 12, and my c is negative 3. Does it open upwards or downwards? The a value is negative 4. Since that's negative, this opens downwards because a is negative. And if you look at the graph, it looks like a frowny face. Okay? What's the axis of symmetry? So again, the rule for finding the axis of symmetry is b divided by negative 2 times a. My b is negative 12. My a is negative 4. Negative 2 times negative 4 is positive 8. Negative 12 divided by positive 8. And that's not going to be nice. I'm going to end up with a fraction. But if I simplify it, I get negative 3 halves. Or you can say negative 1.5. Again, if you leave it like that, I'm going to count it wrong. It's an equation, so x equals negative 1.5. Or you can say negative 3 halves, either way. So let's see what I got here. Here's my origin. I know it's real close at that point. I'm pointing right here. And if I go 1.5 over, here's 1, here's 2. So here's 1.5. And a vertical line, should have used a ruler, but it's okay. So there's my vertical line, and it does go through the vertex. Speaking of vertex, I got negative 1.5. That's okay, you can do this. F of negative 1.5 equals negative 4 times negative 1.5 squared. Subtract 12 times negative 1.5 minus 3. There is nothing wrong with you doing this calculation. 1.5 times 1.5 is 2.25. You can do that. However, I'm not going to stop you from doing this either, okay? So hopefully you guys can see this. I'm going to turn the light on so you can see it. Maybe that's too much. Okay? -4 parentheses, -1.5 parentheses squared. Subtract 12 parentheses, -1.5 parentheses. Subtract 3 gives me 6. So f of -1.5 equals 6. That tells me my vertex is -1.5, 6. And that's not right. I did something wrong. So I'm going to check and see what I did wrong. Maybe I graphed it wrong. Oh my goodness, you know what I did wrong? I just caught it. That's not good. Okay, but I'm gonna call an audible here real quick because it hasn't affected anything yet. When I graphed this on Desmos, I did that. I typed the wrong thing. Okay, so I'm gonna change this real quick. I'm gonna change that real quick, and we're gonna pretend that that didn't happen. Okay. So let's see if everything else is gonna be okay. I'm a little nervous now. -4 times -1.5 squared. Subtract 12 times -1.5 plus 3. And, okay, a lot better. So it's -1.5, 12. See, that's what happens. You type the wrong thing in Desmos and the graph is wrong. Yeah. This point right here is -1.5, 12. All right, so pretend that was a +3 the whole time, okay? You didn't know any difference. Okay, and when you look at it, if you're not watching the video, if you look at it, you'll never know anything else. Speaking of that, the y-intercept is 3, which is right here. And of course, there's the graph of the function. All right. We'll see you in the next video.